This is GACE 023, and the question number is 10. You have basically the multiplication of two functions, and you're given that f of x is equal to x, and g of x is equal to -1 when x is less than 0, 0 if x is equal to 0, and 1 if x is greater than 1. When you're multiplying f of x times g of x, and g of x is a piecewise defined function, basically, and let me just scoot over here, basically you're multiplying that x, the f of x equals x, times each one of these. Okay, so f of x times g of x is actually the function times g of x. It's still going to be a piecewise defined function, but it's going to be negative x if x is less than 0. X times 0 is 0, so it's going to be 0 if x equals 0. And it's going to be positive x if x is greater than 0. All right, so let's take a look at what that looks like. If you want to, you can do a chart. Sometimes that is helpful. Let me do it a little brighter right here. And you could do x, y, and let's just kind of pick up some points on either side of 0. 0 seems to be the place where that hinges. 2, 3, 4, 5. Okay, so there are three parts of this function. There are places where you follow the rule negative x, or the opposite of x, if x is greater than, or sorry, less than 0. That's all of these parts. Okay. Then there is a separate rule if x equals 0. And then there's a third rule if x is greater than 0. So as long as you just follow the correct rule for the given input, you should be fine. So here we go. If I've got f of x equals, I'm following here the opposite of x. So the opposite of -5 is +5. The opposite of -4 is +4. Opposite of -3 is 3. Opposite of -2 is 2. Opposite of -1 is 1. Okay, I flip to a new rule. This rule says if you put in 0, you get 0. It has to be 0 if x is 0. And lastly, x is just x if it's greater than 0. So 1, 2, 3, 4, 5. So if you look at these, I've got -5, 5, -4, 4, -3, 3. So on the left-hand side, -1, 1, -2, 2, -2, 3, and so on. Actually, that's still true, but I just realized that -1 is actually right here. -2 is actually right there. They've got more grid lines than you actually need, but in between would be true as well. Okay, at 0, that second rule said your answer or your output is 0. And lastly, if it's 1, and there's 1, then you go up 1. If it's 2, you go up 2. If it's 3, up 3, 4, 4, 5, 5, 6, 6, and so on. So if you connect those dots, you can see that you have a V, and we have graphed some of these parent functions. This is actually y equals the absolute value of x. So this is a good way to show that this particular function, if you were to separate out the absolute value into 3 pieces, that's what it would look like. So going back to this, the answer is y equals, now you have to think about this just a second, which is equivalent to that. You've got to look at this and determine, is y always equal to f of x? In other words, remember that y is the multiplication of the two. Okay, is it always equal to the f of x or x? No, because on the negative side we flipped it. Is it always equal to the opposite of x? No, it's not always the opposite, because on the positive side it was exactly. Okay, is it equal to the absolute value of the negative of x? No. What about if you absolute valued x and did the function? Would you always get the same answer? Yes. So the answer is D.